So, hello students. So, this is lecture 5, Architecture and the Pin Diagram of 8086. So, in last lecture, we discussed the different type of operations. Those are being performed by the microprocessors. Okay, so, in details, we studied about the registers and the memory, how these operations are being performed. Okay, so now we are going to discuss the internal architecture of the 8086 microprocessor. So, the architecture of microprocessor, here there are two main functional units. So whole architecture is divided into two main functional units. So these units are, so first is what? Bus interface unit. Bus interface unit. As the name is indicated, that interface. So it is providing the interface. So interface. So actually, this act as a bridge between processor and the outer devices. Okay, and basically the main function of this unit is to fetch the instruction or data from the memory. Okay, and next is execution unit. Basically, the instructions or data are being fetched by this unit, and the fetched instructions are decoded then executed by this execution unit. Okay, so these two are main important units of main important part of this architecture of 8086. So let's discuss the architecture of 8086. So this is the architecture of this is the architecture of 8086. So basically this part is what? Bus interface unit. Bus interface unit. Okay, so above from this internal data part, so whole this part is what? Bus interface unit. Okay, and this is what? Execution unit. So basically this is what? Bus interface unit, and this part is what? Execution unit. So main function of the bus interface unit is what? It provides the interface between the processor and the outer device, that is what? Memory. As we know that the data or instructions are being loaded or stored in the memory. So basically the bus interface units fetch the instruction or data from this memory. Okay, so this is what? Outer or memory, and this is whole 8086 processor. So basically it acts as a bridge between the processor and the outer device, that is what? Memory. Okay, so bus interface units sends the address to the memory location. Okay, पर्टिकुलर जो भी लोकेशन से या मेमोरी से मेमोरी की लोकेशन से इंस्ट्रक्शन या फिर डाटा जो भी फैच करना है वो हम बस इंटरफेस यूनिट का यूज करके फैच करेंगे. Basically, this bus interface unit reads the data and write the data into memory, because memory is what? To read the data and to write the data. So basically bus interface unit can read the data from the memory and can write the data into memory. Okay, and basically this also read the instruction from the particular memory location, and this location is defined by this unit. Okay, so bus interface unit का basic function क्या हुआ? Basically it provides a medium or to interface in between the this memory and the 8086 microprocessor. Okay, and this is what? Execution unit. Okay, so first discuss about the bus interface unit. So the main functional part of bus interface unit is what? Instruction pointer, and these are segmentation register. Okay, and one more thing, this is instruction queue. This is called instruction queue, and this is what like a ALU, or this is called 20-bit address generator. This, okay, as we know that microprocessor 8086 microprocessor has 20-bit address line. So there will be the maximum memory uh, that will be equal to 1 MB or 2 to the power 20. It means there will be 20 address line, or physical address will be of 20 bit. So this address generator will generate the address of 20 bit address with the help of code segment and the offset. So different type of index register and instruction pointer registers. Okay, so basically instruction pointer is what, as we have earlier discussed in last class, that the instruction pointer is the 16-bit register that hold the uh, address of the instruction that is to be executed next. Okay, and these are the different segmentation register. So segmentation memory, basically concept of the memory or memory segmentation is already been discussed in your earlier classes. So this is code segment register, data segment register, stack segment register, and extra segment register. So in 8086 microprocessor, the whole memory is divided into different segments. So to store the code, we have code segment. To store the data, we have data segment. And to store the temporary data, we have stack segment. And to store the excessive data, we have extra segment. So basically, this micro 8086 microprocessor supports the multi-user configuration. So because multiple user can access this memory, or okay, so this is the main advantage of the 86 microprocessor or memory segmentation process. Okay, so this is all about the bus interface, the functional units of the bus interface unit. So main part R is what, instruction pointer, segmentation register, and last another part is what, instruction byte or instruction queue. Basically, bus interface unit fetches the instruction while the execution unit will execute them. So what is happening? The bus interface unit is used to fetch the instruction from the memory, and while the same time execution unit is executing or decoding the instructions. Okay, not the same instruction, but this is what prefetched. Basically, there is a concept in the 8086 microprocessor, or that concept is called uh, pipelining. Architecture actually support pipelining, and due to this, the execution speed of this processor will get increased. So actually, what is happening? So main function of the bus interface unit is what? To fetch the instruction or the data from the memory, and which instruction or data is going to be fetched, that will be told by the execution unit. Okay, so वो कौन बताएगा? Basically execution unit will address to the bus interface unit, so that the data is at this particular memory location, or instruction is at particular location, so just fetch them. Okay, so while bus interface was uh, fetching the instruction, so in the same time execution unit will execute the instruction that are being prefetched already, and these prefetched instruction are being stored in this instruction queue. So basically prefetch instruction, okay, so this concept is what, pipelining. Okay, so okay, so because overlapping of the fetching operation with execution operation. So what is opening? Uh, suppose सात first time suppose आपने fetch किया instruction, then similarly उसी टाइम में क्या हो रहा होगा, एग्जीक्यूशन भी हो रहा होगा, जो कि एग्जीक्यूशन किसका, प्रीवियसली fetch इंस्ट्रक्शन का. इट मीन्स कुछ प्रीफेच जो इंस्ट्रक्शन होंगे वो कहीं ना कहीं स्टोर रहेंगे. सो बेसिकली ये इंस्ट्रक्शन जो क्यू है, एक टाइप की एक मेमोरी है, एक टाइप का रजिस्टर है बेसिकली. ठीक है, वहां पे क्या होगा, प्रीफेच इंस्ट्रक्शन सेव होंगे बेसिकली. सो मैक्स इसका साइज क्या होगा, बेसिकली 6 बाइट्स. ओके, 6 बाइट्स एक एट ए टाइम में आप क्या कर सकते हो, इंस्ट्रक्शन आप स्टोर कर सकते हो बेसिकली आपका. ठीक है, तो बेसिकली दिस इज द कंसेप्ट ऑफ द पाइपलाइनिंग. सो ओवरलैपिंग ऑफ द फेचिंग ऑपरेशन and execution operation is what pipelining. So this the prefetch instruction is saved in this instruction byte queue or instruction queue. So there is a queue is nothing, the group of high speed register. This is what queue, and queue basically, so queue basically follow the principle, that is what first in first out. Okay, this is like a FIF. Okay. Okay, so this is all about the bus interface unit. So next we have execution unit. So this is execution unit. So the main part of the main functioning of the execution unit is what? To decode and execute the instructions. So कौन से instruction को decode और execute करेगा? So those are being fetched by the this bus interface unit. So the already pre-fetched instructions are being stored in this instruction queue, and similarly, when the bus interface unit was busy in fetching the instruction, while the same time execution unit is executing or decoding and executing the instruction, those are being pre-fetched and stored in this instruction queue. So basically, execution unit also tell to the this BI unit where to fetch the instruction or data. Okay, so कौन सा data और instruction आपको fetch करना है basically. So this command will be given by this execution unit. So okay, EU also contains some controls circuitry. So this is what control circuitry to perform various internal operations, and here we have at general purpose registers. So this is AX, BX, CX, DX. Okay. So already we have studied this about this in detail in last class. Uh, SP stands for what? Stack pointer, base pointer, SI source index, and destination index. Basically, these are the register bank, and these SP, BP, and SIDI provides the offset. Okay, and this is what ALU will perform the arithmetic and logical operations. So this is what 16-bit ALU. Okay, here this is you can say this adder, or this is also ALU, but this ALU is what? This ALU is different, performing the different task, and this ALU is performing the arithmetic and logical operations, while this ALU or this adder is performing a very important task, that is 20-bit address generation. 20-bit एड्रेस जो जनरेट होगा बेसिकली इस टूल का यूज करके आप जनरेट करेंगे बेसिकली. ओके, one more thing, here we have flags. Okay, about the flag, 16-bit flag register, basically 6 तो आपके स्टेटस सिग्नल और 3 आपके कंट्रोल सिग्नल हम पढ़ चुके हैं बेसिकली. दिस इज व्हाट कंट्रोलिंग सर्किटरी टू प्रोवाइड द to generate the synchronizing signals. Okay, timing and control signal. This is decoding circuit, that is decoding this the prefetched instructions. Okay, okay, so this is the architecture of the 8086. Okay, so now we will discuss the pin diagram of 8086. So basically 8086 is having 40 pin IC and 40 pin IC with dual inline package. Okay, it means 20 pin कुछ इस साइड होंगी और 20 पिन कुछ इस साइड होंगी. So this is dual inline package. Okay, and operating mode of 8086, there are two operating modes. So first one is what? Minimum mode, and next is maximum mode. So minimum mode means minimum mode is for what? Single user, and maximum mode is for what? Multiple user. Okay, and here okay, there are two operating mode, minimum mode or maximum mode. So in this 40 pin IC there are 32 pins for uh, common signals or pin, and 8 is especially used for maximum mode, and 8 is for what? Minimum mode. So it means there are 32, 8 and 8. It means 48 pins? No. So there are only 40 pins. It means suppose 32 pins तो common है और 8 पिन स्पेशली मैक्सिमम मोड के लिए, 8 पिन मिनिमम मोड के लिए. सो आपको एक इसमें स्पेशल पिन है जो कि आपको चूज करना होगा बेसिकली. सपोज वो पिन है आपकी MN और मैक्स बार. ओके, सो अगर आपने इस पिन पे अगर 1 गिवन है इट मींस मिनिमम मोड सेलेक्टेड है, 0 गिवन है मींस मैक्सिमम मोड आपका सेलेक्ट किया हुआ है आपने. सो अगर मिनिमम सेलेक्ट किया हुआ है तो वो 8 पिन जो डेडिकेटेड पिन है वो मिनिमम मोड की तरफ के जो सिग्नल है उसकी तरफ वर्क करेगी, और 0 सेलेक्ट किया हुआ है तो उस पर आप मैक्सिमम मोड के लिए सेलेक्ट किया होगा. ठीक है, सो लेट अस डिस्कस अबाउट द पिन डायग्राम ऑफ 8086. So this is the pin diagram of 8086. Okay, so here you can see that this is 1 to 20 and 21 to 40. So this is 40 pin IC. Okay, and basically it has two operating modes. So first is minimum mode and second is maximum mode. So these pins are identified by this pin, whether it is uh, one is applied at this pin, so it means microprocessor is working in this minimum mode, or if it is 0 then it means it is working in maximum mode. So as we have earlier discussed that there are 40 pins or signals. So out of 40, 32 pins are common and 8 pins are dedicatedly for the maximum mode and minimum mode. Okay, so at a time the processor will work either in maximum mode or minimum mode. So this mode of operation is decided by this pin. Okay, so now we will discuss one by one about this pins or signal. So basically this is 40 pin IC dual in line package. Okay, 20 each side. एंड स्टार्टिंग फ्रॉम द VCC. सपोज VCC आपने पढ़ा होगा, बेसिकली हर आईसी में यूज होता है बेसिकली VCC और ग्राउंड. तो VCC बेसिकली 5 वोल्ट, और नेक्स्ट यहाँ पे आपको दो ग्राउंड मिलने वाले. एक VCC के बारे में हुआ, ये पिन नंबर 1 और पिन नंबर 20. ओके, सो बेसिकली हियर आर टू ग्राउंड्स, टू पिंस. सो पिन नंबर आपका 1 और पिन नंबर 20 किसके लिए? बेसिकली टू कैंसिल द नॉइज. And next is what AD0 to AD15. So pin number from 16 to 2 and 39 pin. Okay, so this is called multiplexed address bus. So this and this one. Okay, so this is what. So AD node to AD15 is what? Multiplexed address data bus. So basically address bus is multiplexed with the data bus. So initially if we talk about the entire operation of the microprocessor, so first step is what? To identify the location of the memory or address of the input output devices. So how it can be done? With the help of the address bus. So initially it means in first T state, first T1 state, okay, so T state is what? One clock period equal to what? One T state, and the bus cycle वन बस साइकिल इज इक्वल टू व्हाट 40 स्टेट. इट्स मींस उसमें ऑपकोड फैच भी हो गया, आपका डिकोड भी हो गया, और देन आपका डाटा ट्रांसफर भी हो गया. दिस इज रिक्वायर्ड 40 स्टेट. ओके, सो इन द फर्स्ट स्टेट वी रिक्वायर्ड द एड्रेस बस. Okay, uh, so AD node to AD15, this is AD15, AD15. So AD node to AD15 will carry the address in first T state. In first T state, this multiplexed address data bus will contain the will carry the address from A0 to A15, and later on in this subsequent state, this multiplexed address data bus will carry the data. Okay, but initially in first T state, this AD node to AD15 will carry the address from A0 to A15, and remaining address are carried by A16, S3 to A19, S6. So it means initially in first state, this 20 bit, so this will become 20 bit physical address. So this is how the 20 bit physical address are being carried out. So this is called multiplex address data bus. Similarly, the status signals are being multiplexed with this address bus. So this is called multiplexed multiplexed address status bus. So initially T state, the address 16-bit address is carried by this 8 address data bus and by this address status bus, and in this subsequent states, this AD node to AD15 will carry the data, and this in this subsequent state, this A16 S3 to A19 S6 will carry the status signals. Okay, so now question arises, how this latching of this address is being done. So there is one more important signal, that is what ALE, address latch enable. Okay, so something is here, this is, so through this ALE the demultiplexing is possible, demultiplexing of address and data bus. Okay, so through this ALE the demultiplexing of the address bus and data bus is possible. So how this latching of this address is possible. Okay, so latching of information or data is possible. So this latching of the information or data is possible with the help of the some flip-flop or data storing element. Okay, latch. So let us discuss about the latch or flip-flop. So this ALE is what address latch enable. So this ALE signal is used to demultiplex the address data bus and address status signal. Okay, so with the help of ALE. So how this is being possible, so how it can be done, so this can be done with the help of what latch or flip-flop. So you know about the latch or flip-flop, about the latching of the information. So latching of the information is what, simply this can be done with the help of the D flip-flop. Simply suppose this is D flip-flop. Okay, so this is what applied input, and this is what clock, and so this is negative age triggered flip-flop. So whenever negative is of the clock, so this is clock negative age trigger. So whenever negative close will come, suppose, okay, this is your clock. Okay, this is positive as, this is negative, and this is positive, negative as, positive and negative. So whenever this positive sorry, negative is will come, so applied input data D will be available at the queue. So this is called what? Latching of the information. Okay. Okay, if suppose these 8 flip-flops are connected together, so this is called what? Octal latch. Octal latch. एंड डेडिकेटली एक आईसी है ऑक्टल लैच, इसको बोलते हैं 8282 और 74373, 74373। ओके, सो किस तरह से बेसिकली यूज करते हैं फ्लिप फ्लॉप का और 8282 फ्लिप फ्लॉप, 8282 ऑक्टल लैच का। सपोज दिस इज 8086 माइक्रो प्रोसेसर। Okay, this is what 8086 microprocessor, and this is what 8282. Okay, and this is what flip A8D flip flop, 8 flip flops are here। कौन सा flip flop है? D flip flop। Okay, this is what clock, ये आपकी clock है, this is common clock। okay, और 8 फ्लिप फ्लॉप है, तो आप मैं 8 इनपुट शो नहीं कर रहा हूँ, बेसिकली एक बस की फॉर्म में शो कर रहा हूँ, लाइक दिस। ओके, सो here we have 20 bit एड्रेस। ओके, 20 बिट एड्रेस। सो 20 बिट एड्रेस को क्या करना है? लैच करना है स्पेशली। सो कितने 8282 रिक्वायर्ड है? बेसिकली आपको रिक्वायर्ड होंगे 3828, 3 ऑक्टल लैच रिक्वायर्ड होंगे बेसिकली, क्योंकि आपके पास में एड्रेस कितना है? 20 बिट एड्रेस। 20 बिट एड्रेस को लैच करना है, इस इंफॉर्मेशन को लैच करना है आपको। सो आपको 8282 मीन्स ऑक्टल लैच मीन्स 8 डी फ्लिप फ्लॉप कनेक्टेड है, तो इट मीन्स आपको 3 ऑक्टल लैच रिक्वायर्ड है बेसिकली। ओके, सो इट मीन्स ओके, so but this line is connected to from AD node to AD15. So 16-bit address will be carried by this. In initially T1 state, the 16-bit address will be carried by this address multiplex address data bus. So this is what 16. Okay, and remaining 4 is being carried by A16S3 to A19S6. okay, and this clock is what? ALE, connected to ALE. So this is the basic diagram of the process, how the latching of the information or address is being done. Okay, okay, we can explain or understand it by one more example. So let us discuss. So basically this showing the latching of 20 bit address. So किस तरह से आपने 20 bit address को लैच किया बेसिकली। ओके, so this is 8086 microprocessor। okay, so this is what 74373 or 8282 octal latch। okay, similarly suppose this is what एक टाइप का D flip flop है, तो इनपुट पे आपका सपोज ओके, सो जस्ट कंसीडर दिस, सपोज आपका ये 8 फ्लिप फ्लॉप है यहाँ पे, बिकॉज इनपुट देखो DI0 to DI7, it means 8 inputs are here, so 8 inputs। so similarly suppose I am showing only one flip flop, it means okay, this only one block of 74, so one block of 74373 containing 8 D flip flops। so inputs DI0 to D7, clock is negative edge, so negative edge, this is connected to what? ALE, address latch enable। so basically this ALE is used to demultiplex the address data bus or address status signal। so basically this ALE is connected to this all 8282 or 74373 latch। okay, so input DI0 to DI7, so here this is applied AD node to AD7, and remaining 8 bits are applied to here to get the A8 to A15। so from this we will get A node to A7। okay, because initially in in first T state, this will carry the address only. So this is 8-bit address, again this is 8-bit address, 8 or 8 16, okay, and remaining 4 bits are from this. So this is called address multiplex address data bus, and this is called multiplexed address status signals. So the 16-bit address is carried by this address multiplex address data bus, and 4-bit address is carried by this address multiplex address status signal. Okay, so this is the basic operation of the latching of the 20-bit address. Okay, so now we will study the buffering the data bus. So in earlier we have discussed the latching of the 20-bit address. So initially in T1 state, the 16-bit address is carried by the AD node to AD15, that is what multiplexed address data bus. So the 16-bit address is carried by the this multiplexed address data bus, and remaining the 4-bit address is carried by this address multiplexed address status signals status lines, okay, A19 S6. And after the T1 state or subsequent states, the data is carried by this multiplexed address data bus, and status is carried by the this multiplexed address status signals. So now we will study the how the data buffering will take place. Okay, how the data is being buffered. So the basically ALE signal is used as the ALE signal is used to demultiplex the address and address data bus and address status signal. So like this, the data can be separated from the address bus and buffered with the help of this bidirectional buffer, that is 74245. Okay, this is what buffer. So the uh, bidirectional two bidirectional buffers are used to separate the data. Okay, so this is what bidirectional. Why this is bidirectional? Because the data can be transferred to the memory, okay, and to the memory. It means write भी process हम perform कर सकते हैं, basically read write दोनों both operation can be performed. So here you can see this is what 8086 microprocessor, and this is AD node to AD15. So this is what multiplexed address data bus. So we have to separate the data from this line. So here there are two signals. Okay, so two signals are being used to control this process. So first is DEN. So the DEN bar. So DEN bar stands for what? Data enable. Whenever data is available to transmit or receive, because as I have just discussed, that this is bidirectional data, bidirectional buffer. Okay, why it is bidirectional? Because data can be transferred from microprocessor to this buffer, and from this buffer to microprocessor. Okay, so to control this process we need a special type of signal, that is what DEN bar, that is what data enable. So if this is low, then it is indicating that data is available to transmit or to receive the data. Okay, so DT slash R bar, basically this indicating the direction of the data, whether it is going to transfer from microprocessor to or whether data is going to transmit or to receive. Okay, so basically whenever it is high, then data is transmitted from the microprocessor, or when it is low, uh, when it is low, then it means data is received by the microprocessor. uh, okay, and this data is being received from the memory or input output devices. Okay, so this is being all about the buffering of the data bus of the 8086. So till now we have discussed about this pin, VCC, ground, AD node 2, and this one and this one. Okay, some part of this. Okay, already. Although we have not discussed about this S3, S4, S5, and 6. Later on I will discuss on this. But starting from this direction, next is what NMI. So basically NMI and INTR. So both are what interrupts. Okay, we have already discussed about the interrupts. There are software interrupt and hardware interrupts. So these are called hardware interrupts. Okay, software interrupt may be in form of instructions. Hardware interrupt are be given by the pin, external pin. Okay, so this pin number 17 and 18 are dedicated for this NMI and INTR. So basically, this NMI is what non-maskable interrupt, and this INTR is what maskable interrupt. And this is also NMI is also positive AS triggered, positive AS triggered. Okay, and this is positive level triggered. Okay, and next is of clock. So clock is what uh, for this we need a clock, and 8086 microprocessor is having 5 megahertz clock. Okay, so standard 8086 microprocessor is having 5 megahertz clock, and there are two more version, called 80861 and 80862. So basically this is 80861 is having 8 megahertz clock frequency, and this 80862 is having 10 megahertz frequency. Okay, so basically this clock frequency, this 5 megahertz, 8 megahertz, or 10 megahertz is generated by using crystal oscillator. Okay, so generally we use in microprocessor to generate this type of clock frequency, we use generally crystal type of oscillator. And next is what status signal. Status signal. So status signal for S3 and S4. This is S3 and this is S4. So S3, S4 and operations. If suppose both are 0, 0, it means extra segment is selected. If this is 0, 1, then it means stack segment is selected. If this is 1, 0, then it means code segment is selected. And if this is 1, 1, then it means data segment is selected. So basically this S3 and S4 is basically used to select the proper segment of the micro 8086 microprocessor. Okay, uh, and the next S5 status signal is basically used or indicating the status of this basically indicate the status of the interrupt enable flag. Okay, okay, already we have discussed about this flag, interrupt flag, and now S6. So basically normally S6 is low. So what is the meaning of S6 is low? So whenever S6 is low, so meaning of this is what 8086 is uses the buses. It means S6 जब भी लो होगा तो it means सारी जितने भी सिस्टम बस हैं, एड्रेस बस, डेटा बस, कंट्रोल बस, all सबका हैंड ओवर किसके पास में 8086, because that time 8086 is using those buses. Okay, but when S6 is high, so it means whenever suppose DMA operations हो रहे होंगे, DMA means direct memory, ठीक है, डायरेक्ट मेमोरी एक्सेस. सो जब भी डीएमए ऑपरेशन जब भी परफॉर्म हो रहे होंगे, सो उस टाइम S6 क्या होगा, हाई होगा. अब ये डीएमए ऑपरेशंस कब हो रहे होंगे, सो सपोज थोड़ा सा एक आइडिया देता हूँ, वैसे डीएमए कंट्रोलर के बारे में हम नेक्स्ट लेक्चर में, नेक्स्ट टू नेक्स्ट इंटरफेसिंग लेक्चर में पढ़ेंगे। इसके होता क्या है, डायरेक्ट मेमोरी एक्सेस। सो सपोज दिस इज माइक्रो प्रोसेसर, okay, and this is what input output, okay, this is input output devices, and this is what memory. So मेमोरी को डाटा जब भी आप, ओके, सो डाटा जो भी मेमोरी में स्टोर है वो अगर आपको इनपुट आउटपुट में अगर आपको सेंड करना है, या इनपुट डाटा जो भी स्टोर है वो आपको मेमोरी में आपको स्टोर करना है, या मेमोरी में डाटा जो अवेलेबल है वो आउटपुट पे डिस्प्ले करवाना है, तो बेसिक प्रोसेस क्या होगा कि मेमोरी से माइक्रो प्रोसेसर, देन माइक्रो प्रोसेसर से अगेन डाटा जाएगा वो कहाँ पे, आउटपुट डिवाइस पे। सिमिलरली सपोज इन अगर डाटा करना है तो इनपुट डिवाइस से माइक्रो प्रोसेसर में एंटर होगा, देन माइक्रो प्रोसेसर से मेमोरी लोकेशन में एंटर होगा। सो सपोज आपके पास में बहुत स्मॉल डेटा है, तब तो ये पॉसिबल है कि आप माइक्रो प्रोसेसर का यूज करके डायरेक्ट मेमोरी से इनपुट आप एक्सेस करो, ठीक है। बट सपोज फॉर द ह्यूज नंबर ऑफ डेटा, सो दिस विल बी द टाइम टेकिंग प्रोसेस। देन क्या होगा कि एक ऐसा प्रोसेस है कि डायरेक्ट मेमोरी से डाटा आप क्या करो, डायरेक्ट मेमोरी से डाटा आप एक्सेस करो। इट मींस सपोज कुछ इस तरह से कि माइक्रो प्रोसेसर का यूज ना करके डायरेक्ट मेमोरी से इनपुट आउटपुट आप डाटा क्या करो, एक्सेस करो डाटा। सो दिस इज कॉल्ड विद द हेल्प ऑफ डीएमए, ओके, डायरेक्ट मेमोरी एक्सेस। सो डायरेक्टली क्या होगा, मेमोरी एक्सेस करेगा, कोई स्पेशल टाइप का एक कंट्रोलर होगा, आगे डिस्कस करेंगे बेसिकली पूरी प्रोसेस। बट बेसिक एक्सप्लेन किया मैंने अभी आपको कि डायरेक्ट मेमोरी एक्सेस की बेसिकली रिक्वायरमेंट क्यों है। सो माइक्रो प्रोसेसर का इसमें कोई इन्वॉल्वमेंट नहीं होगा, तब तक माइक्रो प्रोसेसर कोई ना कोई क्या करेगा, कोई परफॉर्म करेगा, कोई ना कोई टास्क परफॉर्म करेगा। सो ओके, ये प्रोसेस कैसे परफॉर्म होता है, सपोज डीएमए डायरेक्ट मेमोरी एक्सेस को जब भी एड्रेस बस आपको रिक्वायर्ड है तो वो एक माइक्रो प्रोसेसर को एक सिग्नल सेंड करेगा बेसिकली, ठीक है। वो सिग्नल सेंड करने का मीनिंग होगा कि कोई एक एक्सटर्नल डिवाइस जो भी, ओके, डायरेक्ट मेमोरी एक्सेस तो डीएमए कंट्रोलर बेसिकली माइक्रो प्रोसेसर को एक सिग्नल सेंड करेगा बेसिकली। इसका मीनिंग ये होगा कि एक कोई डिवाइस है जो एक्सटर्नली सिस्टम बस मीन एड्रेस बस और डाटा बस को कंट्रोल करना चाह रहा है या अपने हैंड में लेना चाह रहा है बेसिकली। सो इस टाइम क्या होगा बेसिकली कि जैसे ही डीएमए माइक्रो प्रोसेसर को एक इंफॉर्मेशन, एक सिग्नल सेंड करेगा, सो देन माइक्रो प्रोसेसर अगेन उसको एक्नॉलेज करके एक सिग्नल फिर से सेंड करेगा। सो उससे क्या होगा कि बेसिकली माइक्रो प्रोसेसर जितने भी डाटा बस और एड्रेस बस है वो सारी उसका जो चार्ज है वो हैंड ओवर कर देगा डीएमए को। अगेन अब क्या होगा बेसिकली, डायरेक्ट मेमोरी से इनपुट आउटपुट डिवाइस में डाटा ट्रांसफर हो सकेगा। सो बेसिकली ये तो जस्ट केवल इंट्रोडक्टरी पार्ट मैंने आगे डिस्कस किया, एक पूरी प्रोसेस एक डीएमए कंट्रोलर आपके सिलेबस में भी है, तो ये हम आगे डिस्कस करने वाले हैं। यहाँ तो जस्ट केवल इंट्रोडक्टरी पार्ट है, तो मैंने केवल इतना ही डिस्कस किया बेसिकली। So basically S6 is low, it means the microprocessor 8086 is using the buses. So whenever S6 is high, so high, so it means DMA operations are being performed. So till now we have discussed about this VCC, ground, this pin, third, fourth, sixth pin, seventh, eighth, ninth, 10th. Okay. So we have already discussed about this. This is what multiplexed address data bus, and this pin is also at multiplex address data bus. And now this is dedicatedly for the interrupt, and this is for clock. And here we have two ground. Okay, one number pin and two number pin. So actually there are two pins for the ground to cancel the noise. Okay, and we have already discussed about these pins also, because these pins are called the multiplex address status bus, and we have already discussed about these status pins. Okay, so next is what ready reset. Okay, so What about this reset? So whenever we have to reset the microprocessor, so this pin is basically used. And the next pin is what, ready pin. Okay. So ready pin. Okay, we have already discussed about this ready pin. So basically, what is ready pin? So suppose this is microprocessor, or suppose this is a any device, peripheral device that is connected to the microprocessor. So whenever a microprocessor want to access the data from this device, so microprocessor will send a data request. Okay. Okay, as we know that microprocessor is very fast, but peripheral devices are slow in speed. So first microprocessor will send a request to the peripheral device to access or to read or write the data. Okay, so then again in the device simultaneously will after some time uh, device will send a signal to the microprocessor, and that signal is what, ready. If ready is 1, so it means the microprocessor can access this device. If it is 0, it means microprocessor will move into the wait state, or it means the microprocessor will wait some time. Okay. So this is all about the ready and reset. So next is what, test bar. So this is what, test bar. So test bar it's actually what? So during wait instruction. So during this there is one more instruction. Okay, wait. I'm study करेंगे basically. So wait during the wait instruction, the microprocessor will uh, move into the wait state until test bar is equal to 0. Okay. So this is the functioning of this test signal. Then next is MN MX bar. So basically MN MX bar is to select the uh, operation mode of the 8086 microprocessor. So whenever this pin is 1, so it means uh, okay, so whenever the MN MX bar, so whenever it is 1, so it means minimum mode is selected, or if it is 0, then it means maximum mode is selected. And next pin is what, RD bar. Okay, so we have discussed about this minimum or maximum, and next pin is what, RD bar. So this is basically what, read signal. And next is what, BHE bar S7. Okay, so in the next lecture we will discuss about the BHE bar or S7. So you can count this. So we have discussed around 32 pins. Okay, 31 pins, including this BHE bars S7, that will be 32 pins. So these 32 pins are called common signals. Okay, so these are the common signals. So remaining 31 pins are being already discussed by me. So in the next lecture we will discuss the BHE bar or S7. So where we will discuss the one more important concept of the 8086 microprocessor. Okay. So thank you.